Hello everyone. In this video, we are going to learn about an important measure of central tendency called median. In our daily life, we often deal with a collection of numbers such as marks of students, salaries of employees, ages of people, prices of different products, etc. Sometimes we need to find a value that represents the middle portion of the given data. The median is the value that divides the data into two equal parts. When the observations are arranged in ascending or descending order, the median is the middle value. In this lecture, we will learn the definition of median, the steps for finding the median, and how to calculate the median for different types of data. First, let us begin with the definition of median. The definition of median is given as median is the value of the middlemost item when all the items are arranged in order of magnitude, that is either in ascending order or descending order. Now, let us discuss the different types of data series in statistics. In statistics, data are generally classified into three types of series. First one is individual series, second one discrete series, and third one continuous series. In an individual series, each observation is listed separately without showing its frequency. In a discrete series, the data consists of distinct values along with their corresponding frequencies. In a continuous series, the data are grouped into class intervals, and the frequency of observations falling within each class interval is recorded. In the following sections, we will learn how to calculate the median for each of these three types of data series with suitable solved examples. Now, let us see the steps to find the median for an individual series. First, we arrange all the given observations either in ascending order or descending order. So, most preferably, we will arrange the data in an ascending order. Next, we will count the total number of observations and we denote it by capital N. If the number of observations is odd, then the median is the value of n plus 1 by 2th position. That is, median is the middle value of the given data. If the number of observations is even, then the median is the average of the values of n by 2th position and n plus 1 by 2th position. That is, the median is the average of two middle numbers. By following these simple steps, we can easily find the median of an individual series. Now, let us understand this procedure with an example. Let us solve a problem based on individual series. In the problem, they have asked us to find the median for the following data, and they have given the data as 6, 9, 21, 5, 7, minus 2, 0, 32 and 9. We have been given a set of observations and we need to find the median. First, we arrange the given data in ascending order, and it is minus 2, 0, 5, 6, 7, 9, 21 and 32. Let us count the total number of observations. Here they have given 9 observations, so the value of n is 9, that is an odd number. Since the number of observations is odd, we use the formula for the median position as n plus 1 by 2. That is, the median is given by the value of n plus 1 by 2th position. So we just replace the value of n as 9. So 9 plus 1 by 2th position, that is equal to value of 5th. In the arranged data of ascending order, the value of 5th position is 7. So that gives the value of median. So hence the solution for this problem is median equal to 7. Now let us see another example based on an even number of observations. So in this problem, they have given the observations in even term. So totally there are 12 terms will be there. So to find median, first we have to arrange all the given observations in ascending order. So we arrange the data in an ascending order, starting from 1, 2, 2, ending up to 50. So in this example, the total number of observations is 12, that is even. So there will be two middle observation. Let us find these two middle position and then we calculate their average, and that gives the value for median. So first we will find the value of n plus 1 by 2th position. Here n equal to 12. So we replace n by 12. So 12 plus 1, 13 by 2, that is 6.5th position. So since there are an even number of observations, the median position is 6.5th position. As there is no 6.5th observation, so we take the preceding and succeeding integer positions of 6.5, that is 6th and 7th observation. Here the 6th position is 5 and 7th position is 8 in the arranged ascending order data. So we take the 6th position value as 5 and the 7th position as 8, and then we find the average of these two 6th and 7th position, that will give 13 by 2, that is 6.5. So the median for this problem is 6.5. Next, let us see the steps to find the median for a discrete series. First, we arrange the values of the variable in ascending order. Next, we find the total frequency, which is denoted by n. So n is nothing but sum of all the frequency values. Next, we have to calculate the cumulative frequency. The cumulative frequency is nothing but the frequency column by adding the frequencies successively. And then we find the value of n plus 1 by 2th position. Now we have to locate the value of cumulative frequency, which is either equal to or just greater than n plus 1 by 2th position. The median is the value corresponding to the cumulative frequency, which is either equal to or slightly greater than n plus 1 by 2th position. Let us solve problems on median for a discrete series. In a discrete series, the observations are given along with their corresponding frequency values. So in this problem, the marks are considered as observations and the number of students are considered as frequencies. Now we have to calculate the median for the given data. Here we consider the marks as x and the number of students as frequency f. So next we have to calculate the cumulative frequency. So the cumulative frequency is nothing but we have to add the frequencies successively. That is, first we have to take the first frequency 1 as it is, and then we have to add 1 with the succeeding frequency, that is 5. So 1 plus 5, which gives 6. So next we have to add 6 with the succeeding frequency 6. So 6 plus 6, 12. And then we have to add the frequency, cumulative frequency 12 with the succeeding frequency 7. So 12 plus 7, 19. Like this we have to find the cumulative frequency, and the final value will be referred as capital N. So here n equal to 59. So next we have to find the position of n plus 1 by 2th term, that is n equal to 59. So 59 plus 1, 60 by 2, that gives 30th position. From the table, we find that the cumulative frequency just greater than or equal to 30 is 39. That is, the next higher integer value corresponding to 30 is 39. So then the corresponding value of x gives the median value. So the corresponding value of x referred to the cumulative frequency 39 is 8. So the median is 8. That is the solution for this problem. Here we provide another example to find median. The observations are taken as income, that is given in rupees, and the frequency values are given as a number of persons. First we arrange the data in ascending order. In the given problem, the data is not arranged in ascending order. So first we have to arrange the data in ascending order. Then we have to consider the corresponding frequency along with the observations. So we consider the income as x, that is called as observation, and the number of persons is considered to be frequency, that is f. So we arrange the data in an ascending order and we have considered the corresponding frequency. And then we find the cumulative frequency value, that is the frequencies we have to add with the succeeding frequency, that gives the cumulative frequency value. So the first one is 24, and then we add the 24 with the succeeding frequency 26. So 24 plus 26, 50, and then we add 50 to the succeeding frequency 20. So 50 plus 20, 70. Like that we have to find the cumulative frequency, and the final value can be considered as n. Here n equal to 122. Next we have to find the position of n plus 1 by 2th term, that is 122 plus 1 by 2, that is 61.5th position. From the cumulative frequency column, we have to find a value just greater than or equal to 61.5. That is, in this table we can find a value 70, which is a next integer value greater than to 61.5. Then the corresponding x value corresponding to the cumulative frequency x is given by 16,800, and that is referred as our median value. So the median is 16,800. That gives the solution to this problem. To find the median in a continuous series, we use the formula median equal to L plus n by 2 minus Cf divided by f into I. First, we find the n by 2th position. Note that in the continuous case, we use n by 2 instead of n plus 1 by 2. Next, we have to calculate the cumulative frequencies. So from the cumulative frequency, we have to select the frequency that is just greater than or equal to n by 2. The corresponding class interval is referred as a median class interval. So in the median class, we can take the L value, that is a lower boundary of the median class interval. L denotes the lower boundary of the median class interval, and N is nothing but the total frequency. Cf denotes the cumulative frequency of the class preceding the median class. So here we have to consider the cumulative frequency of the median class preceding value, and f denotes the corresponding frequency of the median class interval, and I denote the length of the interval. So using this formula, we are going to solve the problem for finding median in continuous case. Now we consider a problem of solving median. Here the data is given in the height in centimeter in the form of intervals starting from 145 to 150, 150 to 155, and so on, and end up with 170 to 175. So it is given in the form of intervals. That is why we referred it as a continuous series. And they have provided the details of number of students for each height. So we can consider the first height as x and number of students as f. Here we consider the class interval as x and number of students as frequency f, and then we calculate the cumulative frequency. As we know that the cumulative frequency is adding the succeeding frequency. So finally we get the n value as 30. Next we calculate the size of n by 2 position. Here n equal to 30. So 30 by 2 is the 15th position. In the table, the cumulative frequency that is just greater than or equal to n by 2 is 17. So we select the value 17. The corresponding class interval selected to the value 17 is referred as a median class interval. So here our median class interval is 155 to 160, and 10 refers to the frequency of the corresponding median class. Now we select the CF value in the formula. That is, CF is given as the cumulative frequency preceding the median class. Here our median class value is 155 to 160, that is the median class interval. So we have to select the cumulative frequency preceding to the median class. Here we find that 7 is the cumulative frequency value that precedes the median class interval. Here L denotes the lower limit of the median class interval. So our median class interval is 155 to 160. So the lower limit as 155, that can be taken as L. Already we can know that F denotes the frequency of the corresponding median class. From the table we find that F equal to 10, and CF is the cumulative frequency preceding to the median class, that is 7, and I denotes the length of the interval. Here the length of the median class interval is 5, and n by 2 is nothing but the position 15. Now we substitute all the given values in the median formula and simplify the expression. So after calculation, we obtain the median value as 159. Therefore, the median of the given continuous series is 159. This gives us the required solution to the problem. Now we solve another problem in continuous series. Here the marks are given in form of intervals starting from 10 to 25, 25 to 40, and finally end up with 85 to 100. And the frequency is given in form of number of students. Now we consider the marks as x and the number of students as f, and then we can find the cumulative frequency. In the final row of cumulative frequency, we find that the n value as 100. Now we calculate the n by 2th position value. That is n by 2 is nothing but 100 by 2, which is 50th position. The table, we identify that the cumulative frequency just greater than or equal to n by 2, that is 50, is 70. So we select the value 70 in the table. The corresponding class interval to the selected value 70 is referred as a median class interval. So here the median class interval is noted as 40 to 55, that refers the median class interval, and the corresponding frequency, that is 44, is considered to be the f value, and we have to substitute in the formula, and L denotes the lower limit of the median class interval, that is 40, and then we have to select the cumulative frequency value. So it is referred as the class preceding to the selected value. So here the cumulative frequency is 26, that is the class preceding to the selected value 70. So now we know all the data, that is L denotes the lower limit of the median class interval, that is 40, and F is the corresponding frequency of the median class, that is 44, and CF is the preceding class interval to the selected value, that is 26, and I denotes the length of the interval. Here the length of the interval is difference of the interval, median class interval, that is 15, and the position of n by 2 value as 50. Now we substitute all the given values in the median formula and we simplify for it. After calculation, we saw that the median value is 48.18. That gives the solution to our problem. In this lecture, we learned how to find the median for individual, discrete and continuous series. We also understood how to identify the median position and apply the appropriate formula to calculate the median. So thank you for watching the video. Thank you.